So, yeah. So our next speaker is Kathryn Goodenough from BGS, who will tell us about lithium pegmatites, both from Africa to Europe. Please go ahead.
Thanks, Jakob. So I'm going to move from talking about regions to talking about a particular critical raw material. So we're going to focus now in on lithium. And lithium, of course, probably the hot topic at the minute, the critical raw material that the public is all aware of, because, of course, it's an essential component of lithium-ion batteries. And it really helps to have the name of the raw material in the title that everyone knows. And of course, we need those for electric vehicles and for energy storage, but there's a nice Tesla there. And that diagram on the right shows you the change over the last 15 years or so in the amount of electric vehicles on our roads. This is from the International Energy Agency's reports that they do every year, looking at electric vehicles. And when I started doing this talk, I used to say, look at this significant change. There's now almost 10 million electric vehicles on the roads. But last year, in 2023, which is when the last data are for, we were looking at over 40 million electric vehicles on the roads worldwide. That's been an enormous change. Batteries have just become a huge part of life. That's driven by China in particular, but then also by Europe. So we're seeing really significant increases in demand for lithium and, of course, all the other raw materials that go into batteries. So where do we get our lithium from at the moment? Two main places. We get almost half of our lithium from brines, which are mined in the salars, the salt flats, principally in South America, though also in China. And then we get lithium from hard rock deposits, so from pegmatites. And you're going to hear a lot about pegmatites over the next 40 minutes or so. And pegmatites are mined particularly in Australia. That's the dominant producer, but also Brazil, Zimbabwe, and of course, China. They are not yet mined in Europe. And indeed, if we look at this map, and this map is now 3 years old, and I keep saying it needs updating. It really needs updating now. But nonetheless, it shows you the extent of lithium deposits all over the world. And if you look at the blues and yellows there down the western side of the Americas, that's where we've got the young active margin, ongoing subduction. That's where we get the salars and also volcano-sedimentary deposits. So you may get lithium in clays. A bit of that in China too, where they also have brines. But elsewhere in the world, the dominant lithium deposits shown in red are in pegmatites and granites, so in igneous rocks formed beneath the Earth's surface at usually fairly shallow levels in the crust, but still intrusive igneous rocks. And you can see that they extend a lot in Australia, where they are mined, in China, and of course also in other parts of Asia. We just didn't have the data when we made this map. Many places in Africa, I'm going to talk about that a bit more, in Brazil, in Canada, so really all over the world, and of course in Europe. What you will notice is that in Northern Europe, in the Nordic countries, there's really only one spot there. And that spot, of course, is Keliber in Finland, which we've heard about a lot, because that is the most advanced lithium deposit in Europe. And I have borrowed this lovely map from Eric's excellent paper from last year, which reviews critical raw materials in the Nordic countries. And you can see here that with Keliber now showing up in green as the major deposit, that there are several other areas of interest for lithium. And in particular, you can see down there the Stockholm province. Eric talked about the pegmatites at Bergby. And that's another area where there's a lot of exploration going on. But just as Eric has already said, this is what exploration looks like for pegmatites. It is a question of, you might find a boulder, and indeed at Bergby it was found by some students engaging in a mineral hunt, and then you have to drill because everything is covered by forest. And of course, across much of Northern Europe, this is the situation. You probably won't see those pegmatites at surface. They're not going to be easy to find. It's not like Greenland, sadly, where we saw the beautiful exposures that Jakob was showing us. And so there's probably much more in the way of lithium deposits out there across Northern Europe than we currently know about. And there is quite a lot of exploration going on. And all of that lithium that we might find in Northern Europe, we are expecting to be in pegmatites. So when I talk about a lithium pegmatite, what am I talking about? I'm talking about very coarse-grained, intrusive igneous rocks, and I refer to them as lithium pegmatites because they contain lithium ore minerals. And that table just shows you some of the most important lithium ore minerals with spodumene, the lithium pyroxene, at the top. Spodumene is what you really want to find if you want to mine lithium. But they're also known as LCT pegmatites because they might contain lithium, cesium, and tantalum. And indeed, you might also find tin or beryllium. So ore minerals of all of those can be associated with these pegmatites. Now, the reason that they've got such coarse grain sizes is that they're formed from very volatile rich magmas. That's both a positive and a negative, as we'll see in a moment. And they typically form tabular, sheet-like bodies, igneous intrusions that are a few tens of meters thick, maybe in the biggest cases a few hundred meters thick, and laterally extensive over maybe a couple of kilometers. What that means essentially is that in Estonia, all of those drill holes could have very easily missed any sign whatsoever of any lithium pegmatites. And also, they can be internally zoned. So it may even be that if you only have one drill core that goes through a pegmatite, you may not actually see the lithium-rich zones. But the best, the most economic lithium pegmatites are actually not that zoned. You can see here the example, this picture is from Brazil. This is a pretty large pegmatite. That one is heavily zoned, and you can see that it's being mined at several different levels, actually to get at several different commodities in the different zones. Now, a really key thing, and we heard already this afternoon about the importance of a mineral systems approach. For lithium pegmatites, that's a really important thing. You have to understand where you might find them in terms of their geological setting and some of those key features that we've already heard about. You're going to find them in collisional belts. So you want to go and look where there's been continental collision. You're in the roots of an ancient mountain belt where the crust will have melted. You're probably going to find them hosted in metasedimentary or metavolcanic rocks. And you might find them in host rocks of any age. They can be Archean to Mesozoic. But as we will see, there are different characteristics at different times. And what do they look like? Well, this is, I think, the only underground mine that I've been to in lithium pegmatites. This is the CBL mine in Brazil. It's a beautiful mine. If you ever get a chance to go there, I would say don't hesitate. And you can see the pale-coloured lithium pegmatite and the darker-coloured host rocks. You can see the very sharp contacts between the two. That is an absolute characteristic of these lithium pegmatites. On the top right, you have some core from Ghana. All of those bladed crystals are spodumene. That's your lithium ore mineral. And you can see this very clear unidirectional growth texture with all of those crystals being parallel. And really not much variation. These things can be really quite homogeneous. As you can see in the big picture there from Brazil, there's very little variation. In fact, that particular pegmatite has spodumene crystals that are taller than me. Now, I know being taller than me isn't that difficult, but still. And then down here, we have an example of the pegmatites from Bergby. And again, you can see those bladed spodumene crystals that are all parallel. So this is what we're looking for. But if we want to find them, if we want to take that mineral systems approach, then we really need to understand how they formed. And this is something about which there's still an awful lot of debate. So the traditional view on how lithium pegmatites formed was developed by Peter Cherney, who was working in Canada on these rocks for many years and who did a huge amount to support of our understanding of pegmatites in general and lithium pegmatites in particular. But he developed a model that's really the classic model, and there was this idea that you had a parental granite, which for lithium pegmatites would be an S-type, so formed by melting of sedimentary rocks. And around that parental granite, as it As it crystallized, as it underwent fractional crystallization, you would get melts that were more and more enriched in incompatible elements and also in volatiles. And eventually those very enriched melts would escape from the cooling pluton and move out along fractures or other pathways in the crust to give you this roughly concentric regional zonation around the granite. And in that situation, you would expect to find your lithium pegmatites at a fairly consistent distance from your parental granite. And that model persisted for many years. But now we really understand that things are not that simple, and magmatic systems in the crust don't always work that way. And now we have, through some fantastic early career researchers that have been publishing over the last few years, and a research that's really been going on in the last decade, I think we have a better idea of how these systems work. We start with sediments that were probably enriched in lithium, potentially because they formed in one of those active margins like we see down the western side of the Americas today. And those might have been, they might have had a volcanic source, they might have been evaporitic, they may just have been clays deposited in closed basins, but for whatever reason, a bit of enrichment in lithium. Then, caught up in a collisional belt, those sediments have undergone metamorphism and eventually melting. And a lithium-rich melt, because these are incompatible elements, lithium will be released into the melt very quickly as melting starts, and these are often quite volatile rich melts that will coalesce and begin to move through the crust. And so we have this idea now, this concept of the transcrustal magmatic system. May have small magmatic bodies in it, large magmatic bodies, mush zones. And in that kind of system, these lithium-rich melts, broadly granitic in composition, would have the opportunity to coalesce into larger bodies of melt and maybe undergo fractional crystallization. Maybe they freeze in pegmatites, for example, and then are remelted. But as they rise up through the crust, they undergo all these processes to become more enriched in lithium. You have to get to about 10,000 parts per million lithium in the melt to get to the point where you can crystallize a lithium pegmatite. And this, we don't fully understand all the components of this process. We don't yet really understand the details of the source or the details of that evolution, but we certainly know it's happening in plenty of places because we see a lot of lithium pegmatites around the world. But then another really important point about lithium pegmatites. As I just said, they form from really volatile rich magmas. And that means that as the magmas cool, you get, first of all, magmatic crystallization. You often get spodumene, quartz, and feldspar. Those are the first minerals to crystallize. That would be a perfect lithium deposit. But you've got all these volatiles there in the melt. And so what we tend to see is really extensive hydrothermal alteration within our lithium pegmatites. And that makes really complex textures and mineral assemblages. And that's really important because it's one thing to mine, but once you've mined, you have to produce what we see in the middle. That's a spodumene concentrate. That's about 6% lithium oxide. And then you have to process that to produce the lithium chemicals that go into batteries. We're going to be talking more about all of this tomorrow. And if you've got a really complicated mineralogy, then that's going to be really much more difficult to do. So you really have to understand your mineralogy and textures to know, do we have an economic lithium pegmatite that's going to be worth mining? And indeed, this is based on a paper that we published a couple of years ago. We've established, and many others have done similar work looking at this, the paragenesis in lithium pegmatites is kind of fourfold. You have a magmatic story, then you get albitization or sodic metasomatism, followed by a more potassic metasomatism, and finally, as you get down to lower temperatures, the whole lot can alter to clays. And if you don't capture a lithium pegmatite somewhere in those first couple of steps, it's probably not going to be worth mining for lithium alone. So I want to take you away from Europe for a moment and take you to Africa, because as has already been pointed out, there's a lot of work going on in collaboration with other geological surveys in Africa, and that's something we've been doing a lot at BGS. And in Africa, there is a huge amount of exploration expenditure going on and a lot of interest in lithium. This is a sort of simplified geological map of Africa. The pink is the Archean cratons, the blues and purples show you the mobile belts, mostly Proterozoic, around those Archean cratons. And what we've recognized is that there's a number of different phases of pegmatite formation associated with different orogenic belts. So if you're, didn't mean to do that. No, I'm going to give up on the laser. If you're in the Archean, there are really good, big lithium pegmatites in Zimbabwe. In the Paleoproterozoic, and I think we've heard a lot about the Paleoproterozoic today, incredibly important period of the Earth's history for critical raw materials. If you're up here in West Africa, in the Paleoproterozoic, when you had subduction, accretion, and collision going on, really prospective for lithium pegmatites. In the Mesoproterozoic, you want to be in Central Africa, where there's some really big lithium pegmatites, and that belt stretches from Rwanda and the DRC all the way down to Namibia. And then in the Neoproterozoic, there's a lot of pegmatites being formed as well, associated with the Pan-African orogeny. So the last sort of major coming together of all the different cratons to make Africa and indeed to make Gondwana. And this is in press. This is coming out in a special volume on lithium, a special volume of economic geology that's coming out very soon. What we've recognized by getting together all the people who are working on lithium pegmatites in Africa and talking about the different deposits, what we've recognized is that each of those different orogenic events across Africa has a slightly different fingerprint for its pegmatites. So when you're in the Archean, you've got large pegmatites in greenstone belts in the Archean cratons, and they have a very complex mineralogy. You tend to have petalite, but that's been replaced by spodumene intergrown with quartz and other lithium minerals. So these are big lithium deposits, but they're complicated. They're not that easy to process. In contrast, in the Paleoproterozoic in West Africa, you've got beautiful coarse-grained spodumene pegmatites, a bit of albitization, sure, but really these are the sort of thing that you're going to be looking for to mine, because processing-wise should be relatively easy in that you're using processes that are well understood. You come into the Mesoproterozoic, and we've probably all heard about Central Africa and the 3 Ts, the conflict minerals. These pegmatites are much more highly albitized, and much of the mining has been for tin and tantalum, which you find associated with that albitization. There are some really good lithium deposits, but some of those pegmatites are perhaps less interesting. And then the Neoproterozoic in Africa, you get really complex pegmatites, like this bottom picture here with these great big tourmaline sprays. They're often mined for gems, but in terms of lithium, you tend to find most of the lithium minerals have been replaced. So this is a continent-wide perspective. Of course, it's a generalization, but it's a really useful generalization because if you know the geology in a certain country or region, you can start thinking, well, what might be most prospective for really good lithium pegmatites? And what about in Europe? So this is from the lovely paper by Blondine Gourcerel and others in 2019. And this highlights the main areas of interest for lithium in Europe. Now, in the center there, we've got the Vrysken orogeny, and that is the belt where maybe most of the lithium exploration is happening. But those lithium deposits are all a bit complicated. They're mostly granites, some pegmatites, and in a lot of cases, the lithium mineral is lepidolite. And lepidolite is really challenging to process, and outside of China, no one's doing it at the moment. There's some deposits in the Alps, in the Alpine orogeny, and some of those are being explored. The cledonides, I wish that was more interesting because, of course, we have a large chunk of the cledonides in the UK, but so far, not that much is known in terms of lithium deposits in the cledonides. There are a couple of lithium pegmatites. There's a big dot there over one in Ireland that I think we may hear about more momentarily. The really interesting area, without a doubt, and we're coming back to the Paleoproterozoic, is in the Sphecophennian, where we have the Kelleber deposit, the Bergby pegmatites we've just been talking about. But again, those are spodumene pegmatites, a bit albertized, variably albertized, but as in Africa, the Paleoproterozoic seems to be where it's at, which is why this is really important from the point of view of Estonia. So just to sum up there, lithium is a critical raw material, or critical mineral, as the UK government has termed it, and we're expecting demand to grow really rapidly. There's exploration for lithium pegmatites all over the world, but there is this fundamental challenge that most lithium pegmatite deposits, they start with a discovery outcrop that looks something like these pictures here. Maybe it's boulders, maybe it's the tiniest little outcrops in the laterite, or even just bits of mica in the laterite. Maybe it's just a forest. They're very difficult to explore for, and they're difficult to find. We need to build those exploration models, which we're working on really fast, and we think there's many more opportunities for lithium pegmatites to be found across Northern Europe. But what I will say is we really need good exploration tool sets for pegmatites. And that is setting you up, Axel, so I thought you'd smile at that one. Thank you very much.
Thank you, Kathryn. We're a little behind schedule, but there's time for one or two quick questions. Yeah, go ahead, Eric. That's a microphone coming there.
Thanks for a very interesting talk, Kathryn. Very, very interesting was the point you made of the different orogenies in Africa and the different character of pegmatites. Though I could see some direct trend there that is it really different orogenies having different characteristics, or are you just seeing essentially a net effect of paleocrystallization depth due to different ages?
That is a really interesting question, Eric, and you're absolutely right. We don't know whether whether this is down to crystallization depth, which of course we can't measure in pegmatites. We have no geobarometers at the moment in pegmatite mineralogy.
You have mineralogy. You have mineralogy.
Yes, but the mineralogy, so you have the spodumene to petalite, you have that geobarometer, but since in almost all of these spodumene is what you see, also bearing in mind that sometimes you have spodumene and petalite together, which makes it a little more difficult. So you may be, for the Archean, perhaps you're looking at different crystallization depths, but otherwise I actually think that more likely you're looking at something to do with variations in the source down to environmental conditions and so on when the sources were formed. But you're absolutely right that at the moment we don't know the answer to that.
And it kind of fits with having myrolitic pockets in the youngest ones.
Yes, indeed it would. You're quite right. So the shallowest are the Neoproterozoic ones. But then interestingly, when you get to the Alps, where you would think you were really in very shallow examples, you have good spodumene pegmatites, albeit variably albertized. So I'm not convinced at all that it's that simple.
Thanks. Any other questions?
Yeah. Okay. Thank you, Kathryn, for an insightful presentation. When you describe this paragenetic alteration, your 4 stages, is that a closed system or an open hydrothermal system process?
Yeah, absolutely brilliant question. One we really are trying to answer at the moment. We know, and I expect Axel may talk about it in a moment, we know that the fluids from the lithium pegmatites are lost at some point because you start seeing these halos where you have lithium enrichment in the host rocks. So we know at some point it becomes an open system. We don't know when that is. We haven't yet done significant amounts. Nobody has done significant amounts of, for example, stable isotope work to really try and track that. There's been 1 or 2 studies, I would say, that have suggested, well, clearly at some point the system becomes open, but exactly which part of the system, which time in that paragenesis the system becomes open, yeah, I don't have a general answer for at all.
Could I make another observation? If it's just reflections on the paucity or lack of Archean spodumene or pegmatites in Finland compared to, say, Australia. And many of these partially melted anatectic terrains are probably more metaluminous than. So is there another comment compared to the more paraluminous S-types melts you might have? Is there any significance in that?
Yeah, I don't know. That's a really good question. My feeling is that the only place where the Archean has been really, really well explored for these things is Australia. And also, obviously, in Zimbabwe, they've been well discovered. But I do wonder, when Jakob was talking about Greenland, for example, I thought, gosh, are there really no lithium pegmatites in Greenland? Seems quite unlikely. I think in general, exploration for lithium pegmatites, except in those few places where they're really well exposed, it is very difficult. And as a result, I think we're looking at just a few pieces of the jigsaw, trying to work out what the jigsaw is going to make in the end.
Thanks. I think we have to move on to the next talk.